Hello viewers, in today's session we are going to discuss this important definite integral involving a mod function, and here we have to evaluate the integral that is from 0 to 1 by 4, and here the integrand is mod of sine 2 pi x, right? So let us call this integral as I. So here we'll first make use of the method of substitution, and then will apply some properties of mod function and sign convention of trigonometric functions in four quadrants. So here let us substitute theta is equal to 2 pi x, right? So here we introduce this variable theta, and we'll take theta is equal to 2 pi x. Let us differentiate theta with respect to x. D theta over dx is equal to d by dx of 2 pi x, and we can write 2 pi, and here the derivative of x with respect to x is 1, so this is 2 pi. So d theta over 2 pi is equal to dx, right? And here x varies from 0 to 1 by 4, so let us change the limits accordingly. When x is equal to 0, then the value of theta can be obtained from this expression, that is 2 pi times 0 is equal to 0. And when x is equal to 1 over 4, then theta is equal to 2 pi times 1 over 4, and here we have pi over 2. So when x changes from 0 to 1 by 4, theta varies from 0 to pi by 2, right? So now this integral I can take the form in terms of theta, that is theta varies from 0 to pi by 2, and here we have mod of sine theta. For 2 pi x we write theta, and for dx we can write d theta over 2 pi. So now taking 1 over 2 pi outside the integral, we have 0 to pi by 2, and here we have mod of sine theta and d theta. So let us now apply the definition of mod function to this integrand, that is mod of sine theta. Now see, we know that mod of p is defined as positive p whenever p is greater than 0, and mod of p is 0 when p is equal to 0, and mod of p is equal to negative p whenever p is less than 0, right? And here if we look at the four quadrants, then here we have theta 0, here we have pi by 2, here we have pi, here we have 3 pi by 2, and then we have here a 2 pi. So this is the first quadrant, this is second, this is third, and this is fourth, right? Now here the value of theta, it goes from 0 to pi by 2, right? So it implies that we have to restrict ourselves to the first quadrant only. And from trigonometry we know that all the six trigonometric functions are positive in the first quadrant, right? So here sine theta is greater than 0 when theta belongs to the first quadrant, right? And in other words, we can say that when theta belongs to this interval, that is 0 to pi by 2, then sine theta is always going to be positive, right? So if we take sine theta as p, then mod of p, that is mod of sine theta, is equal to positive sine theta when sine theta is greater than 0, and theta belongs to this interval, that is 0 to pi by 2, right? So now we have 1 over 2 pi, and we have 0 to pi by 2, and mod of sine theta can be replaced by positive sine theta here, and the integral of sine theta is the negative cos theta, and limits are from 0 to pi by 2, right? So now we can write this negative sign outside here. We have minus 1 over 2 pi, then we have cosine theta, and limits are from 0 to pi by 2. Now we can substitute the limits and we'll take the difference. So we have cos pi by 2 minus cos of 0, right? So now the value of this integral is equal to minus 1 over 2 pi, and cosine pi by 2 is 0 and cosine 0 is 1. So we have minus 1 over 2 pi times minus 1. So minus times minus, this is positive. So we have plus 1 over 2 pi, right? So the value of this integral is equal to 1 over 2 pi.